Good morning, ladies and gentlemen. Good morning, everybody. I am Florence Guedas from the International Agency Nantes-Saint-Nazaire, and it's a great honor to welcome Carlo Ratti here in Nantes today. Carlo Ratti is an architect and an engineer. He shares his life between Italy and the United States. He is a worldwide reference on smart cities and runs the Senseable City Lab at the MIT, where he explores the built environment of cities, from street grids to garbage systems, using new kinds of sensors. When the digital and physical worlds are converging, what impact does this have on our way of life? Last time he came to Nantes at Les Ateliers de la Création in April. He presented us the Copenhagen Wheels, a project about transforming a conventional bicycle into an electric hybrid. Let's see what he has to show us today. Ladies and gentlemen, please welcome Carlo Ratti.
Good morning, everybody. It's a great pleasure to be back here. Can we have the lights maybe a bit down for the slides? But what I'll do today, actually, I thought because of the theme of the conference and because of some of the things actually happening that have been happening here over the past few days, I thought that I'll try to put together more like an overview, different points that are changing, we believe, the interaction we have with our cities. So I structured the presentation around these kind of different points that I wanted to share with you. And I want to say a couple of things. First of all, if there's any question in the middle, feel free to raise your hand or interrupt. And then if not, we'll have also a little bit of time at the end for more interaction and comments and questions and so on. So the thing I want to start with is this picture. It's a picture that people used to be really fascinated about in the 1990s. People at the time thought that actually digital would make our physical world less and less relevant. Because of digital, it would be less important to move, to travel, to meet. In the 19th, there was a book called The Death of Distance. So distance would not matter anymore, physical space would not matter. So much so that some people even thought that cities would not matter anymore. That's Gilder, an American writer, 1995, said, cities are leftover baggage from the industrial era. Well, what does it tell you? This thing. The first thing it tells you is actually don't ever predict the future, because it's very easy then to screw up like he did. No prediction could have been more wrong than this one. And well, we know that actually what has happened with cities is cities have been thriving over the past few years. That's a picture from China. China itself is building this century probably more urban fabric than all of humanity ever built before. We know that half of the world's population now lives in cities since 2008, and actually this number could swell to 5 billion by 2030. So what has happened is that digital hasn't really killed physical space like Gilder said, but digital and physical are kind of recombining. They're creating a new hybrid dimension. It's a dimension of ubiquitous computing, of digital intelligence everywhere. And so they're creating new potential for understanding cities, for designing them, and ultimately for exploring the way we can live in them. And this is the field that many people call smart cities. We like to call it more like sensible city, hence the title of the presentation. Within the sensible puts a bit more people instead of technology at the center of all of this, but it's really based on this hybrid condition, bits and atoms coming together with us in the middle. Now, based on that, I tried to put together kind of 10 points of different interesting directions of what is happening, and these are some of the things we are trying to explore both in our lab and in our design office. The first one is about something you could call public participation 2.0. Over the past few years, we saw a lot of pictures such as this one, pictures from the Arab Spring. But think about also the Occupy movement and many other different things that would have been very different without ways of actually, for people to connect in real time and synchronize in real time. Things that are actually just a few years old, such as Foursquare, Twitter, Facebook, and so on, actually allowing people to respond in real time. And, well, then the question is, what if actually you could channel the same energy, not really for politics as in the Arab Spring, but actually to fix the city on a daily basis. And that's actually what the mayor's office in Boston is working on, with a project called the Urban Mechanics, New Urban Mechanics. The idea really to make people like mechanics of the city, not only because you can report problems in your city. That is quite common now, that you can actually say there's a problem in the road or the bus stops and some other places. And that's very important. You know, if you do it right, they will actually save you a lot of money. In the old days, actually the mayor's office or the city council had to send out people after a storm or a big whatever event in order to check what the issues were in the city. Now, if you do it right, you actually have all this information for free collected from citizens and also prioritized, because, you know, people will report especially the most important things, the things they care about. But actually not only reporting, but actually more and more actually saving and responding to this information. So how you can then take action in different ways. And we are seeing very interesting ways of communities coming together to fix issues after a storm, after the snow, and so on. So that actually before you had to wait for somebody else to take action. So again, you know, this kind of new way of participating in the management of the city on a daily basis. Now, there's another dimension to this, and that is actually how this can also help us to better understand communities. What you see here is actually a map of the UK. I thought it would be quite topical today, this project. And you see all of the different parts of the UK. What we did there was actually build the largest ever social network. It was a non-internet social network. It was built using data from British Telecom, using billions and billions of data points of connectivity. And then we started to ask ourselves, how could we actually better understand communities using this information, like this? Sorry. So every time you got a phone call, you build a link between two places. And if you aggregate this across all of the country, you get something you could call the human network of how we're all connected with each other. And then you use this and you try to understand how, you know, you can better understand boundaries based on this information, communities based on this information. And the interesting thing is that you don't find a geography based on politics or based on the past, but you actually find a geography that's based on a natural way we all interact with each other. And what you saw there before briefly were actually the old boundaries and the new boundaries that you find. Sometimes they're very close, like in the case of Scotland. Actually, the boundaries that you find by doing this are very close to the existing boundaries. In other cases, actually, they're different. And you probably saw that Wales was actually quite different than the Wales we know, and the centre of Wales had been actually attracted to the centre of England by some of the big cities over there. So almost like how you create, again, you know, a geography that's really based on the natural way we all communicate with us, and how you understand communities, really based on the interaction that we have. You know, and there's many applications. One of the things we've been discussing with them Prime Minister's office a couple of years ago in the UK was actually how could you use this type of information, for instance, to redraw constituencies in the country, and so to better understand again, you know, how constituencies are shaped, not because of past and traditional information and historical information, but actually because of connectivity between people. Now, a lot of these things actually happen through new interfaces we have. And these new interfaces really are a key part of what all of this field of you know, the smart city. There are interfaces that we are very familiar with that allow us to book whatever, anything from a restaurant in real time to, of course, to a car with things such as Uber. And, you know, there's more and more of this. And that's really crucial in order to give us and tell us in real time what is the availability of a restaurant, of a car, of an Airbnb, and of many other things. So one of the important things here is actually how we can put together all this real-time information from the city and share it with citizens. And this is actually what we are doing in Singapore with a project called Live Singapore, where we're trying to take all data streams, a lot of real-time data streams from the city, and actually then allow people to analyze them and visualize them. So you see what you saw there was actually people based on the data from the cell phone network in the island, his energy consumption and temperature. When it gets hotter, then you see everybody turns on the air conditioning, so energy consumption goes up. How everybody goes to Marina Bay for the Formula One Grand Prix, so how the city responds to special events. Taxis and rain here. Look at how taxis disappear when there's rain, so you can't find a taxi there. The rain are the little spots you see at the top. How the island expands and shrinks during the day because of traffic jams. And then how actually all of the local flows connect with the global flows. So that's all the container and the people into Singapore and out of Singapore. So, and then all of this information actually is collected in different ways from the city. And here I use, a city where everything talks is based on an exhibition. It was at MoMA, the Museum of Modern Art in New York a few years ago. We were part of that. The idea that, now the city can talk back to us. And that is done through a lot of sensors in the city that collect information and send this information back. Many types of sensors. Sensors that tell us, what something is. But other sensors we can actually develop, deploy, and use in the city. For instance, in this project, what we did, we looked at this computer. Now, if you take this computer to know, today, you know everything about it. All the chips inside this computer, you know where they were produced, how they moved on the planet, how they became this machine. However, a few years from now, you stop using this machine and you know very little about what happens to it. Sometimes this is what happens to it, to a lot of e-waste and electronics in our homes. Shipped legally, sent somewhere, sometimes shipped illegally to developing countries. So our idea was, what if you could actually take a little tag, develop a tag, that we could put on trash, and then start following trash. We couldn't find anything off the shelf, so we actually worked with Qualcomm, a big chip producer, manufacturer in the United States, in order to engineer, these tags. And then after developing the tags, they're like miniature cell phones that you can put on trash, and then they allow you to follow trash. We started, first a deployment. This is the first deployment in the city of Seattle. And after tagging all of them, we started following them. See the day of deployment. After a few days, you see some of the main landfills next to Seattle. But it's actually a big surprise how far things started to travel. Sometimes in a crazy way. Traces all across the United States, left and right. Still moving after 1 month and 2 months. The Fireworks Symphony was the right music for this. Well, so what can you do with it when you got this information? The first thing you can do is actually get all this information, mine it, and try to design a better system. So discover interesting things, how sometimes, how different pieces of waste go in different ways, move in different ways. Sometimes, as you saw, in crazy ways, things going left and right, east and west. So how much energy you could save by actually making the system more optimized. You also something like this, you can look at where things go, and here what you see is the list of all the EPA facilities. Actually, look at something interesting. Here is all the waste facilities and the recycling facilities in the United States. And well, what do you see? Well, what you see here is actually that the recycling are mostly placed in cities. And you see New York and all the big urban areas are there, where actually the landfills are in most of the rural places. You see the difference in color between the two, which is quite interesting. It is, if you got enough land, people will just throw things there. Well, actually, if land is more expensive, such as in a big urban area, people will try to recycle at least a little bit in order to waste a bit less and put less stuff in the ground. And so you can actually look at this and combine this information with information from the traces, from the traces we saw before, and try to see how you can optimize the system. So, use this information to better understand what is going on and probably try to optimize some parameters such as energy consumption, transportation, and so on. Now, the other thing you can do is actually you can share this information with people, with the users. And, this incredible amount of data we have today, big data, big urban data, when you share it with people, then it's interesting because it promotes behavioral change. We have more information about our environment then, and we can make different decisions. Something interesting was, and we did this in the project, so people would get something like this that told them about what they threw away, where it went, and how. And something interesting was somebody at the end of the project came to us and said, I used to drink water in plastic bottles every day and then throw them away and forget about them. And now after the project, I know they go a few miles from home to a landfill and they will stay there forever, so I stopped drinking water in plastic bottles. So the idea that all of this, actually, big data can help us know better what's going on around ourselves, as I was saying, and then take better or different decisions. We learned that a third thing that was actually more unexpected from the project, and that happened more recently when a burglar came to our lab at MIT. And the poor guy stole a lot of things, including a lot of the tags in the computers that tell you where they go. And this is what happened. All right. So, you saw what we can tag and follow and put tags and sensors on almost everything, even on trash. There's something, however, that's so that means really we can use this information in a pervasive way in cities, and sometimes actually ourselves. So people can become the sensing agents, or we are the one who can collect information about the environment. In the next project, what we did was actually work in Hong Kong and Shenzhen. It's a project from a few months ago, and where we actually were concerned about air quality. Air quality is very important. It's very important in China today. In Hong Kong and Shenzhen, our two cities are very close. They're almost like one city, but they're on two different sides of the border, or the Chinese border, and air quality is very different. And again, with the idea that this information, if we collect it, if we share it, it can promote action, civic action. In this case, perhaps people to put pressure on the government in order to do something. Or in a simpler way, also, if you know air quality in your city, you can actually decide to go jogging or to move with different routes. So we started doing this, actually, by using sensors that people could carry and share this information with others. We called the project One Country, Two Lungs. When actually Hong Kong went back to China, the slogan was One Country, Two Systems. And so 2 lungs, as we are focusing on the air that people breathe in on 2 sides of the border. All right. Well, what you saw is we looked at a lot of flows. We looked at flows of waste and people moving through the city. And actually, mobility itself, in general, is probably going to be affected immensely by some of the changes we are discussing here today. Today we can understand the city in a different way because of all this real-time information coming from the streets. What you see here is actually Lisbon. It's a map of Lisbon using billions and billions of data points from the taxis moving through it. Again, you could not have seen or plotted or understood the city like this just 15 or 20 years ago because this information was not available. And then we got this information, you can actually analyze it and do interesting things. In this case, it's, again, taxis in New York City. You see every pickup in yellow and drop-off on the taxi system. What you see here, actually, just this zoom is on the JFK airport. For those of you who know it, you see all the terminals. But you can look at the whole city. So you see all pickups and drop-offs in the whole city. And then you can ask yourself, what if people could actually share some of this mobility? As we said before, we are sharing plenty of things thanks to the availability of real-time information from homes on Airbnb and other platforms. And mobility is probably, it's quite easy to share. People do it naturally, did it naturally in the old days. There were many similar systems before digital. So now today we can do it in a much faster and efficient way. So what if people were able to share mobility? Now, for us, this was not a startup idea. For us, this was imagining that people would do this, and then we are interested in kind of doing research in order to understand what would be the consequences of this on the city. So when you want to do that, you need to actually take all this data. Again, we're big data in cities. Try to analyze it. Now, if you wanted to analyze or to address such a problem in the old days, you would probably use linear programming. But with this amount of data, then linear programming gets very tough. So what we did, we developed a system that was published just a couple of weeks ago in PNAS, the Procedure National Academies of Science. And the system we developed is something we call shareability network. It's a way that you can take this dynamic problem and turn it into a static problem by seeing which trips could be combined. And then you run an optimization process on the trips. And you ask yourself the question, so if people were happy to share with a certain delta in the delay they can accept, say 1 or 2 minutes, maximum 5 minutes, that you can accept as delay in getting to your destination. What is the minimum infrastructure you would need in your city in order to take everybody to their destination? And the interesting thing you find is that it was very surprising for us is actually you could take everybody where they need to be, more or less when they need to be there, give or take a few minutes, a couple of minutes, with 40% less infrastructure than what you have today, which is what you see on these curves. And the interesting thing is that if you subsample the taxis, so if you look at a lower density of taxis, New York has a lot of taxi, very high taxi density, which is not the same as in other cities. But then if you subsample, you see that the curve saturates very fast, which means actually that you'll be able to run such a system also in cities with a much lower density of taxis. As a matter of fact, that's one of the things we are actually doing now to compare different cities across the world. So the interesting thing is that basically you are able to use a much linear infrastructure and still be able to satisfy the mobility demand of a whole city. Well, this is about how we have all this information in the city, this digital information in the city that helps us, the city become, if you want, more intelligent. Now something similar is happening inside our cars. Our cars as well are now full of sensors, know a lot about us, know a lot about the environment, and they're changing as well. In this project, for instance, what we did was put a lot of sensors inside the car in order to better understand the conditions of the driver.
We just finished the drive. It was incredibly stressful. It was the most stressful drive I've ever been on. Nevertheless, I think we have a lot of great content to measure road frustration because I'm certainly frustrated at this point. And we're off. Jesus.
That wasn't planned.
Oh God. Okay.
Stop the car.
So we were just sideswiped. And right now my stress level should be through the roof. We got the information, we'll have to process the data and see where it's really at.
Shit. Jesus.
All right, so basically the city is becoming more intelligent, if you want, the car is becoming more intelligent, and at the convergence of the two, something quite extraordinary is happening that I'm sure you've heard about, which is actually autonomous or self-driving cars. Now, we are not interested in autonomous car or self-driving cars, because you don't need to keep your hands on the steering wheel. That is not the point. But the point of self-driving cars is actually, this is what you see from a self-driving car, is how the self-driving car looks at all the environment and scans it with, like a 3D vision system, a LiDAR system. So the point of the self-driving car is actually that the car in the morning can give you a lift to work, and then can give a lift to somebody else in your family, or to anybody else in the city, for that matter. So instead of having a car and a piece of infrastructure being idle somewhere most of the day, you can actually use it more efficiently, and you blur the boundary between public and private transportation. And when you do that, it becomes very exciting, because if you combine this, which is car sharing, vehicle sharing, what I was just saying, the vehicle, you use it and then you will give a lift to somebody else. If you combine this with ride sharing, which is what we saw before in New York City, then the combination of the two means that you could have a city where you use just around 20% of the infrastructure you have today, and you can still satisfy the mobility demand of, say, New York City or Paris or Nantes or any city on the planet. So approximately, that depends on some local conditions. So imagine how our cities will look like if you remove 4 cars out of 5. They go. And just with the others, you can still actually run the city in an efficient way. So that's why we are excited about self-driving, really about the urban impact of self-driving. When everything will be self-driving, a few years from now, other things will change. Traffic lights started at the beginning when a lot of cars got onto the road. But then, when everything will be self-driving, then you can think about different systems, more intelligent systems than traffic lights, something like this. Don't try it yet. Slot systems, this is not our work, but is another team. What we've been doing recently is actually try to quantify how better could the system be if you were to do this. And incidentally, if any of you is in Paris, there's a small pavilion called the Wave Pavilion. It's in the Parc de la Villette. And where this is actually shown with an installation, you can actually see how many cars are coming, where they're coming from, and then compare a traditional system with a slot-based system, which is what you see here. And they'll go a bit faster just to show the results. You see just it's exactly the same amount of cars coming. To the left, you see how much the jam you generate and the delays you generate, and actually to the right you see how better the system is in terms of both delay and capacity. So these are some of the things we are looking at from kind of the mobility point of view, and the impact of self-driving, not really because of the technology, which is almost there on the vehicle, but actually for the urban consequences of it. And I'm going a bit faster because we want to keep some time at the end for interaction. But, we saw this about mobility, but energy. The same thing is happening in other fields, such as energy. One interesting thing is that in energy, today, we put energy to heat buildings that most of the time are empty. Again, there's a lot of infrastructure which is not used efficiently. There's a paper where we looked at what happens in the MIT campus and actually where the energy goes, and you see that actually many times it goes into heating places where there's nobody. Of course, something like this, which is Nest, a thermostat, an intelligent thermostat that learns from you and so on, is a good way to address that issue, and that's why it's been successful. But then we thought, what if you could go one step further and look not only at changing energy or the use of energy over time, but actually at changing over space. Imagine you don't need to heat the whole room anymore, but you can actually just have a bubble of heat that follows you as you're moving through the room. We did a test in front of MIT during the winter. So the people coming into MIT would actually have this little bubble of heat that they could customize as well. So you could say, I want to be at 25 degrees, 22, 17. So you can actually have this personal heat bubble that follows you. This was quite fun and successful. We're now testing this at the Venice Biennale. There's an installation right now. I'll show you a little video now that shows how the installation was put together. Now, in the installation, it is quite present because they wanted us to make it visible, to make it a bit, almost a bit baroque. But you can think about this as something that's seamlessly integrated into a false ceiling. And it actually helps modulate heat as people and occupancy change in a room or in the building. Here's the video from the Venice Biennale. And so this is a biennale still for a couple of months. And this is about how, in the end, allows you to have environment that respond in a different way to us, and you can use it for architectural reasons, or you can use this in order to make our architecture again something like we were saying before that talks back to us, something that responds in a more dynamic way to people. In this project, it's a project we did with with Zaragoza, with a city in Spain that got the 2008 World Expo just before Shanghai. And at the time, the mayor came to us and said, the theme of the expo is water. Water has been a beautiful ingredient of planning, of architecture, of urban planning for thousands of years. How could we use it today in a different way because of digital? And one idea that came up, so we did a workshop, and one idea that came up was, imagine you have a pipe, and on this pipe you've got many valves, many tabs, opening and closing controlled by a computer. So effectively, almost like a water printer. You can print water and turn on and off all of these tabs, and then you get something where you can show images or text or patterns, where actually the water wall can respond to people, like a living wall. The guy approaches it, and it opens up to let him in. The mayor liked it, so we got the commission to build the building at the entrance of the expo. Called Digital Water Pavilion. The whole building is made of water. No doors or windows, but when you approach it, it opens up to let you in. Then when you're inside, also all of the walls expand and shrink based on how many people you have. The roof is also covered with a thin layer of water. Then if you got too much wind, you can lower the roof to minimize splashing. Or at the end of the day, you can actually close the building and the whole architecture disappears. Hopefully without anybody underneath. We got sensors for that as well. That's the building before the opening. So this guy was stopping by, trying to figure out what the hell is happening there. Here was actually water and projections on the top of it. Here's what myself trying not to get wet. And I should tell you now what happened one night when actually all of the sensors that detect people stopped working. And that night we were terrified because the building would keep on doing its own crazy things and cuts and holes and text and writing, but without responding to people anymore. But actually, that night was one of the most fun nights ever. That night, thousands of kids from all over the city came to the building, not to have a building that opens up to let you in, but to engage with the building in a different way, like this. And for us it was important because as we design more responsive things, a more dynamic system, then also sometimes things will not go the way we expect them to go. And it's very important to take this dimension into consideration when looking at interactive responsive designs. We've been working on many other, there's many other projects, I will not go through them, that try to explore this more interactive living dimension of architecture. Is a proposal we did for Mayor Johnson, the Mayor of London, for the cloud and interactive digital physical system in the city. But I will not go through them because I want to start wrapping up and leave a bit of time at the end. The first thing I wanted to share with you is something about, all of this is changing the way we really think even about knowledge, in the way we come together to do things. We used to think that knowledge was something like this, where everything could be in the right spot, like at St. Thomas' time when he wrote the Summa. Now if you had to think about a map of knowledge, perhaps it looks a bit more like this. This was on the cover of Nature, the scientific journal, and it's actually a map based on 800,000 papers and all the links between them. And you see these beautiful connections emerging between brain research and computer science and mathematics, social sciences, so where everything, as in the internet, is connected to everything else. Even in Nature also looked at the most important papers in the past and the most important papers today, based on impact factor. And, based on citations. And the most important papers in the past usually were by one author from one very well-defined discipline. Today, the most important ones actually come from many authors from many disciplines collaborating together. And we think it's very important. That's what we try to do at the lab every day, really working together to look at a problem, trying to not really to look at disciplinary boundaries, but actually to jump and have people from different experiences, different backgrounds, different nationalities coming together and looking at things with different eyes. And of course, that's going to have a big impact on universities and the way we teach. I think people in the United States are quite concerned that if you look at media, the media sector, it has been incredibly disrupted by digital. Think about Newsweek. Newsweek was one of the pillars in publishing, was a very important weekly magazine in the United States, and one day vanished, disappeared from printed form. And all of this is because of the changes imposed by digital. Well, the business of university is not about news, but it's about knowledge, producing and disseminated knowledge is not that different, and probably universities 10 or 15 years from now will be very different than what we know today. MIT is experimenting with MITx, with edX. Many other universities around the world are experimenting with digital platforms. The solution probably is not to be only digital, it's going to be a combination of digital and physical, but it's probably going to change a lot what we mean by actually going to university. And the same, I would say, applies perhaps also to production. Well, you've all seen probably Discovered by The Economist. The Economist usually is quite understated, but Third Industrial Revolution is quite a bold title. What is this about? Well, this is about all these kind of new systems that allow us to go from something on a computer into printed. Now, some people think that a few years from now you will not need to go and buy an iPhone. You could just download the drawings on the iPhone, and then you print it in the basement. That will still take a bit of time. If you take the iPhone today, a good chunk of the pieces in here you can digitally fabricate, laser cut, or produce by some processes are based on reduction or on cutting. Some other processes are based on addition, such as printing. So a lot of pieces you can do that way, but actually not the whole thing yet, and not in one single line. So actually then you need to take different pieces and assemble them. But still, the changes over the past few years have been incredible. 10 years ago, we were using 3D printers at MIT in order to do models made of powder. They were interesting, but they were only a way to look at the shape. And as you might know, since last year, GE is starting to 3D print jet engines or parts of jet engines. So you can 3D print in metal and use this stuff in your everyday life. This is a project, the Copenhagen wheel, that was mentioned before. In this project would be very different if we hadn't done a lot of 3D printing, both to develop the prototype and also for the final production. So that is probably going to change a lot. Again, not necessarily, well, it's going to change a lot production itself, but it's going to change a lot the city as well. Because, if you don't need to have a big factory outside the city anymore, then, you can have factories, production going back into the city. It's not the old type of production, it's kind of a cleaner production, digital production, but you can put it back, close to where people are thinking about how to do new things. Oops, sorry. And, the final thing I wanted to share with you is about how all of this is probably going to change also the way really we live and work in the city. That's a quote by Le Corbusier. So in the Chart d'Athènes, apologies, I use the Italian translation here, but basically he said, in order to improve cities, we need to separate everything. All the parts of the city for residential, for working, for living, and for leisure, and for connections, for transportation, all of them need to be separated. But if you think about this, that creates like a crazy situation where you have 3 different cities and all of them are empty most of the time. So since the 1950s and 60s, many people around the world, Jane Jacobs in the United States, but many others, said, no, we actually need to have mixed-use developments where actually you put a little bit of everything. But today, perhaps, this is going one step further. And let me try to explain to you something that could actually radically redefine the boundary between public and private space and really the very structure of our building. Now, let me give you an example. So if you look at this, that's the MIT campus. You see Boston downtown, the Charles River, the MIT campus, like a little city in the city. Harvard, don't bother, up there. And MIT campus was one of the first ones to be totally covered, blanketed with Wi-Fi. That was a decision of Bill Mitchell, dean at the beginning of the 2000. And it was one of the first ones all across the world to be totally covered, but that produced an incredible change in the way of living and working. Students used to work, as you see there to the left, and now they work, as you see there to the right. Now, this is happening, has since happened in most universities around the world, but what we decided to do is, can we actually quantify the changes? And, you know, all these changes are being brought along by the network. So what if we actually monitor the network in order to better understand what is happening? So we looked at all of the access points on the MIT campus, and then by mapping activity, you can actually see how people move through the campus and how people work in one place and then another place. What you see here is actually people waking up in the morning and then going to the classrooms, going to eat, and you see all these bubbles tell you how many people are in each part of the campus. Well, this is, for instance, the activity that you get as overall activity. That's a Monday. On a typical Monday, you got people getting to MIT around 9 o'clock. 9 to 5, you got kind of the peak at 5 o'clock. Some people leave, but most people are still in a lot of activity is still there on campus. That activity continues till quite late, dinner time or even 10, 11 p.m. Even in the middle of the night, you got quite a bit of things happening on campus, and the same happens on Monday, on Tuesday, on Wednesday, on Thursday, not on Friday, like today. As you see, activity slips away in the afternoon very, very quickly. And then you got Saturday and Sunday, which are almost like normal days, if you remove just the 9 to 5 people. So still a lot of activity happening there. Also, with something that happens every Sunday night, you see here a little dent around 9 or 10 p.m. And that's on Sunday night when people say, shit, tomorrow is Monday again. And you realize all the things you haven't finished during the weekend. So if you take this and you look at the signature for every space on campus, then you analyze it. You see, you know, that is a signature for every room. Every room has a different occupancy profile. And then you look at all of them, you analyze them, you do clustering, you can use eigendecomposition, you can use Fourier transform and combine them together. What you find then is exactly what we were saying before. Is really the fact that actually the use of those spaces is becoming much more mixed. We are more mobile, so we can actually appropriate any space as an office space, just with the laptop. And so the boundaries we had before, those boundaries are kind of disappearing. The boundaries, not only the boundaries Corbusier was talking about, but the boundaries that actually Jane Jacobs was talking about by all these little bricks of residential office and so on, that the use of space is becoming much more blurred. And that also means that we can use the square meter in a more efficient way. Again, it's a little bit of the same thing we saw about cars. You know, we don't need to have a lot of empty spaces that are used just for one function. We can actually overlap functions over time, and then we use the square meter, the square footage, in a more efficient way. And this is something we're trying to use in different design projects. This is a project in Mexico where we're designing a new city that tries to use this principle. This is a project, a small project we did in Milan, in Italy, in the main square. It's called Piazza della Scala. It's for one of the fashion houses called Trussardi. And what we did there was actually try to imagine this place, which is a Dior, but not just as a place for having a coffee, but like an extension of people's living room and offices nearby. A place where you can go there, you got this big table, you can have a meeting, you can actually do some work, meet friends, use it as a conference room. So really an extension of some of the places nearby. And since then it has become very successful, so it's always very busy and active. And not only as a place, as I said, where you go and eat something or drink something, but actually a place where many other activities can be overlapped. And I wanted to finish with this picture because we started with technology, we started with digital, and we looked at many aspects of it and how it is transforming our cities. But in the end, there's something quite amazing here that the most interesting effects are the one where digital totally disappears, are what Mark Weiser would call calm technologies, when digital is totally in the background. And then we can focus on the important things which are the things that are the reason why we've been creating cities for thousands of years, which is coming together, enjoying each other's company, creating good environmental conditions, and, and making sure that the total of us being together is more than the sum of the individual parts. Thank you. Thank you.
Thank you very much, Carlo, for this inspiring, impacting, challenging, visually stunning talk. And thank you also for being here, because basically you crossed the Atlantic to come to do this talk and come back. It's a short story, but this is close to that. And
no, thank you. Thank you. It's always a pleasure to be here. Again, I unfortunately this time a bit quickly, but it's always a pleasure to be here. I think we have still a few minutes for a bit of interaction.
Sure, that's exactly what I was. Are there any questions in the public?
Comments or ideas? Yeah, I see two hands there.
Thank you for this very, very interesting talk, really. I was asking myself for one point. When we see all the projects you have presented, it seems that we can only use smart city approaches for rich urban areas. Do you think so, to make life easier, to help to solve some urban problems? Do you think that we can use such kind of approaches for areas which are more isolated, or countries which have more important economical, social, and problems, especially that we don't have a very well-developed technological infrastructure?
Yeah, totally. Thank you for asking this question. Actually, this is a very important point. Yes, I think so. I think actually something that's very encouraging to us is the fact that more and more people are using some of these technologies to leapfrog. If you think about, if you look at some parts of Africa, you've got people using and having developed mobile payments much more than in Europe or the United States. If you look at very interesting things happening in India or in Sri Lanka, where actually fishermen are able to use real-time information to create better markets, so they can, before they didn't know exactly what the price of some things, such as fish, was, and then so people could take advantage of them, and now they actually know in real time what the information about the price, and because of that they can create a better market and not be exploited. So there's many interesting examples all around the world that show actually how a lot of these things we're talking about can benefit and can have great application in not only in developed countries, but also in emerging countries. And we're also working, as we speak, we're working in different projects in South Africa, in Brazil, in Indonesia, and so on. However, I want to tell you something. Just, so the bottom line is that yes, there is a lot of potential. However, I want to tell you something as an analogy. When something like this started, around 30 years ago, it really started to be deployed. This was actually, cell phones were actually very expensive, and they were only accessible to a small fraction of the population. And now you got the condition where actually almost everybody, just 2 or 3 decades later, almost everybody on the planet has access to cell phone. In some places, people don't have running water, but they have a cell phone. Now, the news from the past few weeks is actually there's a new smartphone coming out at $25. And, at that point, it means that the connectivity, not only cell phone, but smartphone abilities, will actually be accessible to everywhere on the planet. So what I'm saying is that every technology has a kind of an adoption rate. And this has been the same all across human history. And so it shouldn't stop us. We should always think about how this can benefit everybody, and we should always think how we can make sure that the technology doesn't reinforce separation. It's not a technology only for the rich. But still, I think it's still okay if you do experiments, provided they can trickle down to other parts. If you do experiment at the beginning, which are just in some parts where people have easier access to the technology. The fact it should not have stopped, the fact at the beginning when the smartphone came out, if no cell phone but smartphone came out, you know, the fact it was quite expensive should not have stopped developing the app ecosystem, because tomorrow this can really benefit everybody on the planet. So, so there's two answers here. The first is, yes, a lot of these technologies have a lot of potential for emerging countries and for addressing other problems than the ones we've seen today. But still, the fact that every single technology has an adoption curve that starts somewhere and then trickles down shouldn't stop us to focus first on some population and then making sure that this can then benefit in the end, ultimately, also all the others. Yeah. Thanks.
Many other questions?
You never talk about software, the software part of the infrastructure. En fait, is free software a condition? In fact, for free smartphone or cheap smartphone, and for the cities at all.
It is a great question. And it's a question, you know, that you can apply. You can talk about free software. You can talk about, in different ways, about Creative Commons. I mean, what do you want to leave open and what do you need to keep closed? And I think that today there's a little bit of a polarization. So, you know, you got two camps. It's almost radical, where you got, on the one hand, people say, you know, everything should be open. And then on the other side, you got big companies and so on who say, oh, my God, no, you know, I think that was Steve Ballmer said these crazy things a few years ago. You know, you cannot leave things open that will destroy the system. And so you got this kind of polarization, these kind of two radical positions. What I think is actually that if you listen carefully at what most people on the open side say, well, the goal there seems to be the maximum impact. So the decision seems to be motivated by the question is, how can I have the maximum impact with the thing I do? That can apply to something you develop at the Fab Lab and you have some drawings and you keep them open so that other people can replicate it. They can develop to a piece of software that can apply. They can apply to many other things. So the idea behind seems to be the idea of the maximum impact. How can humanity benefit in the maximum way from this? And then I think that the answer is not always evident. In some cases, yes. You know, it's good to keep something open that people can replicate, and you got a beautiful example that we've seen over the past few years. In other cases, it might also be better to keep something closed, because then you might have the funds to develop it further, and especially, so for instance, let me just give an example. I think that probably if Steve Jobs had, not done the iPhone, but just put the idea and the drawings online, I'm not sure if that would have been really picked up. It was very difficult to pick up. So you really needed the power behind in order to engineer the supply chain and so on in order to make this happen. And this certainly has changed and transformed the world. So I'm not sure if this would have been possible at the same time, at that time, a few years ago, just by saying, hey, we could do something like this and here are the drawings. And if you add to that something interesting that we are starting to explore, which is, what if you have something close, but then the revenue that you get, you reinvest in society. So, the revenue is not revenue that is extracted for somebody's benefit, but it's reinvested in a project. So if you look at all these different models, I don't think there's just one answer. But according to what you're talking about, in some cases, it may be good to keep everything open from the beginning. In some other cases, it might actually be good to keep it closed. But then, the revenue that is generated is reinvested in similar projects, in the same project, or in society. And I think, again, then the metric becomes something else, becomes maximum impact, and how do you achieve it?
Hi. One of my concerns when I think about smart cities and the development of smart grids, for example, which can obviously optimize the use of energy or the optimization of car traffic, is that there are maybe unthought consequences which are linked to the privacy question, if you want. There is, I think, a problem of engineering which we have to deal with, because we can, I think it could be a threat to or privacy, I think. What do you have to tell about the risk on these questions?
Yeah, I think it's a very good question, but I would say this is a much broader challenge. So I don't think it's only about smart cities. You know, this is about the fact that everything in our lives is being recorded and stored somewhere. So actually, we are digitizing our physical world. You know, what has been happening over the past few decades is actually creating a digital copy of our physical world. And you know, because is much more profound what you're saying than just looking at smart cities. What you saw here in a certain sense is using this data component, this data dimension in order to, you know, make the city work better, do an interactive piece of architecture, in order to change the interaction we have between humans and the city. But actually, the thing which is behind, which is all the digital component, the huge amount of data we are collecting, that is something much more profound than what we've been discussing here. And I think you're right. That is something we should all look very carefully at. Let me make an example now. Nobody ever thought that taking picture would be something bad. And, you know, if you were in the same room here just 15 years ago, 10 years ago probably, then, you know, very few people would have taken pictures because pictures were analog. And what would happen is that you take a picture and then you had to pay in order to print it. And then once it was printed, you couldn't search it. It would end up in a drawer, stay there for like 10, 20, 50, 100 years, and at one point disappear, being thrown away. So nobody ever thought that actually taking a picture was a problem in terms of privacy. Now you fast forward just 10 or 15 years, and here in this room you have certainly more cameras than people. All of your phones have at least 1 or 2 cameras. Every computer, there's a few, has some. You know, people were beaming, were taking pictures or videos during the past hour. And a lot of this stuff is going online when you can search it, you can search it, you can tag it, you can index it. As you know, it's just a matter of time. There was a debate with Facebook a few months ago about, you know, should they allow automated face recognition so that you actually take a picture and you know more or less with a good accuracy who that person is on the planet. There's actually a few scientific papers that show that that is quite feasible with good accuracy. And then when you put all this together, then even something as easy and innocent as taking a picture, something nobody ever thought would be a problem, could become a problem. And that is really part of this kind of digitization of our physical world. Now, the consequences of this are quite profound. One consequence, they are creating a society where it's going to be much more difficult to forget. And you all know how important it is to forget. You know, when you need to recover for whatever relationship or something else, you know, forgetting and not thinking about something is very important. Here we are archiving everything, so it's going to be much more difficult to forget. For those of you who are interested more from a literary point of view, there is a writer called Italo Calvino. In the 1950s, late 50s, I believe, or early 60s, he wrote a short, so before all of digitization, before Google and all what we know today, he wrote a short story called The Memory of the World. And he really starts from this condition. He imagines that humanity is able to record every single thing that happens on the planet. And he starts from that as a starting point, and then just after a few pages, you see that that condition immediately turns into drama, intrigue, and ultimately murder. Now, that is a short story, it's fiction, but still, some of the points he highlights are very important points. What happens in a world where everything is stored, who has access to that information, and what is the impact that the information has on us? Now, it would be too long to talk about what the solutions could be. There's many out there. I'll tell only one thing, that is it's very important that we all talk about these issues. And what we did at MIT for the second time last year was organize a forum called Engaging Data. Last year we actually had Noam Chomsky, professor and activist at MIT, together with Ed Snowden, who leaked a lot of NSA data, Ed Snowden's lawyers, and many other people really talking and debating this for 1 year. Because I don't know what the solution is or should be, or I have my ideas, but the point is that we should all debate these issues because societies we will build tomorrow will depend on the decisions we make today. So thanks for raising the question. Yeah.
Thanks for your talk. The talk had, in fact, two quite different facets. One is observing, and the other one is acting. And these are vastly different. And when you are acting, digital becomes a little less attractive because of the fact that you cannot really count on robustness of many mechanisms. For example, if I take your street crossing, which is in principle very interesting, I think that software and sensors in cars are far from the reliability, which is, because the solution is very interesting, but much more dangerous if you have failures. And so acting is quite different and needs much more care than observing. So what do you think progress can be made in this reality? For example, reliability of sensor there is not what people think.
Yeah,
by far.
I think it's a very good point. And actually, I want to put this slide on, which is about sensing and actuating. Exactly what you are saying. Some of it is really sensing and actuating is the basis of any real-time control system. And it's what every dynamic system does or living system does. When we see each other, we sense each other, and then we respond to that information. Now, what you're saying is interesting. I think that we should always look, even if there's only what you call sensing. Well, you do sensing for making some decisions. So sometimes, even if you just collect data about trash and how it moves, you're still thinking about actuating. You're still thinking about how they can help us in order to change the system. So what I would say is that, I would say that there's always an actuating component. But the difference you're making, I think, is that sometimes this actuating component is in real time. Sometimes it happens automatically. So, I think planning, if you take the planning of a city is a way to actuate. You collect a lot of information from the city. You have some ideas of how it could develop, and then you use that information in order to plan the city and to actuate the system, to transform it, to change it. But it happens over a long period of time. Well, actually, I think what you're saying is actually the real-time actuating system. And yes, you're totally right. The reason I showed the project in Zaragoza and what happened to it is that when you got this loop, then something can happen there. And it might behave not as you imagine. Now, we're all familiar with what happens when our computer crashes, when a virus crashes our computer. But our cars are becoming like computers on wheels, and what if a virus crashes our cars? That is actually, when you create cyber-physical systems that have digital and physical together, then that is what can easily happen. And so I think that together with this kind of convergence of digital and physical, and we've seen some examples over the past few years. All of you remember Stuxnet in Iran. All of you have seen, most of you have seen the James Bond movie, the latest one, that actually the whole thing is based on the same thing, and actually how you can change the software in order to have explosion or to transform the city for something bad, to hack the city, to change and transform physical space. So when you combine digital and physical, the question is that if something happens to the digital, then you're going to have something very bad on the physical side. And I think that one of the important things will be, over the next few years, will be to look at all the redundancies we actually need to build into the system, both on the sensing side and the actuating side, in order to avoid some of this. Because otherwise, it's just a matter of time, as you say, and it's something that's very present today in people's mind. People who work like on autonomous car, that's a computer on wheels, and somebody could hack it, or somebody could, for whatever reason, the system could fail. Because somebody's hacking it, or just because it fails, and then that's a big problem. And so I think we'll need to work a lot really over the next few years on all of the redundancies we need to build into the system, both on the sensing side to make sure the data we collect is good, and on the actuating side, how we respond to that data. Yeah.
I don't know, it's 10:15, Carlo. Are you taking another question?
Yeah, sure, with pleasure. And then I think, it's the last question.
Yes, it's follow on the privacy question, but on a more pragmatic way, asking you have told us how real-time data, availability of real-time data is key for the smart city and the new experience in the city. So I'd like to ask you how in your projects you have managed that. You have one leg on each side of the Atlantic, the different approach on privacy on both sides. And so how did you proceed to have these data available and make them anonymized, pseudonymized? What was the process?
Yeah, no, this is a very good question. Well, first of all, let me say that in a lot of this, it's a little bit like what happens in biology. And, in biology, it's probably even more extreme, that, sometimes people need to create, the way you can address some of these questions is by creating an ERB, ethical review board, or basically by saying, how should I use, there's something new out there. And sometimes there's not even regulation yet on how it could be used, and then you want to have a review board actually trying to look at it and say how you should play with it. And I think that's more common in other disciplines who are pushing the boundaries, say of when you look at biology and DNA and so on. But I think we need to do something similar when we have maybe a new type of data that's unregulated, or in a country where it's unregulated, and you want to ask yourself, how do you use it? Well, you want to have this kind of self-reflection about, what am I doing here? Who's going to benefit for it? Can I have some third parties look at what I'm doing and, and assess it? So that's more like a methodology thing that you want to have in research. Now, the ultimate goal, however, of what we are doing is really research. In this case, is about using some of these data for better understanding a city. And we really saw this at the beginning when we started working with cell phone data in the city. That was quite unregulated space. We anonymized everything. We usually told the company we didn't want to have any single bit of non-anonymized information on our servers. So basically everything was anonymized before it reached our lab. But we saw that in one of the first, we did some of the initial work on using cell phone data in cities. That was now 10 years ago. And at the time, the space was very unregulated in Europe, in the US. Now, 10 years later, it's quite interesting because there's quite good regulation in place of what you can do for a commercial point of view. On the other hand, some companies such as Orange in this country has been one of the pioneers in actually opening up some anonymized databases and sharing them with researchers. There's actually one competition is going on at the moment about they took a chunk of cell phone data for, they did last year for Côte d'Ivoire, the African country. This year they did for another country, I don't remember which one it is, but there's a competition going on right now where they made the data public so that actually scientists could look at it and explore it and so on. So, and that's, in just 10 years, you got quite good regulation on what you can do with it on the commercial side. And on the research side, you're getting more and more openness, provided that you satisfy certain criteria in order to get access to this data. So again, I would say on the one hand is about following what happens in other fields and having like an ERB, and on the other, when you are on new turf, if there's something that's totally new and you don't know how to behave. And on the other hand is actually following the regulation as it comes into place. So I would say these are the two things.
Okay, so let's thank you again very much for your
Thank
talk.
you. Thank you. Thank you. Thanks.